So let's start. Any other questions? Okay. So now let's discuss about type 5, right? So type 5 is nothing for, it is for use for L3 EVPN, right? Layer 3 EVPN. So basically in layer 2 L2 EVPN, we were exchanging, MAC address and IP, ARP information, right? ARP and MAC routes, and also flood list information. So in type 5, we will advertise IP prefixes information, right? So the field, right? The field will look like this. So it will have route distinguisher RD, right? Ethernet segment identifier, it will be 0 for MLAG, and for multi-home only it will be non-zero. Ethernet tag, right? IP address length, IP address, the IP address, right? Route which we want to advertise to other peer. IP prefix, gateway IP address, right? Which is nothing but this VTAP IP address, which will be gateway for this next hop for this IP address route, right? And then VNI label, right? This is VNI. And then we also have route target, extended community, RT, router MAC extended community. We will see this, right, when we'll discuss more about L3 EVPN. And tunnel encapsulation is nothing but either data plane is VXLAN or MPLS. Okay. So these are the fields which, we are going to use for type 5, right? Let me quickly show you the packet capture to get more idea of it. So this is the two VTAPs, 255.3 and 255.1, and basically 255.3 is advertising type 5 route to this another VTAP, right? And there are many update messages you can see. So let's go through one, right? So for it starts with BGP normal attribute, right? Path, origin, AS path, and then it is local preference, right? Local preference, and then MP reachability NLR, right? In which we are more interested. So again, AFI next hop, right? What will be the next hop? So this is the VTAP IP address, right? So this VTAP will be the next hop for all the routes, right? And then NLRIs, right? Different type of NLRIs. So type 5 is called IP prefix route, right? So let's see. So what are the information it will have? So it's type 5, right? Route type. So it starts with type 5 route type, right? And then it will have RD value, route distinguisher value, what is configured on this VTAP. Ethernet segment identifier is 0. So RD Ethernet segment, Ethernet tag is also 0 in this case, right? It's a VLAN base. If it is IP prefix length, so this is the IP prefix and this is the length of that prefix, right? So this route we are advertising 10.1.10.0/24, right? So this is the packet, basically prefix. Gateway address is 0 and then VNI, that is the VLAN, right? VLAN to VNI mapping. So this will be the routing information. So if you see here, so this is one route, right? There are other routes as well. So this is another route we are advertising, that is 10.255.1.3/32. Okay, and the third route is also there. Third prefix, basically 10.1.11.0/24. And for all these three, the next hop is the one which, initially we have seen, that is this VTAP IP address, right? So that will be the next hop, this one. Okay, so basically we are advertising three different prefixes which is originated on this VTAP3, right? So similarly, if we want to check the another update, okay, well, let's go through the other, right? Then we also have extended communities where we have route target, right? Route origin, from where it is originating, right? So that is this VTAP IP address. And then encapsulation, whether it's a VXLAN encapsulation or MPLS encapsulation, and EVPN router MAC. So this is basically nothing but MAC address of your VTAP, right? Because when packet has to come back, right, you need to know what is the MAC address of the destination MAC. So we will see in more detail, right? But yeah, basically this is the MAC address of the source VTAP who has advertised this. So MAC address of this 255.3. Okay, so we'll discuss about this when we discuss more on L3 VPN. So yeah, this is one. If we want to check the another one, that's again MP reachability NLRI, right? Next stop is same, and then we are sending extended community. Next stop, yeah, this is NLRI. This is IMET route. So this is type 3 route. Okay, so this one has type 3 route. And what about this? This is also IMET route, type 3 route. Okay, so basically multiple update message. The last one is type 5 route where we are sending routing information, right? Prefixes. Okay, any question?
In the previous advertisement, right?
Yeah,
The
yeah,
gateway was 000.
yeah, right. Actually,
Shouldn't that be the next stop IP?
yeah, man, that's right. I think even I was also surprised when I looked at it. Let me go through. I'll come back to you on that. Right?
Okay.
Why gateway is 0?
Okay.
Oh, sorry, this one, right? Yeah. Yeah, this gateway was 0. I also want to check, right? What is the reason for this? See, anyway, next stop address is here. So we know that this is going to be the next stop address. I really want to understand then why this is 0. Maybe I'll look into it more and see why it's 0. Or maybe is it because locally originated and means, yeah, let me come back. There is. Okay, any other information or any other question? Okay, so yeah, this is what about type 5. We will discuss more on type 5 and we'll discuss about type 3 VPN. But as such, there is nothing much difference. Almost all the fields are same, except instead of MAC or ARP information, we are sending IP address and length, right? And the gateway field is new. But other, and also router MAC extended community, that will be extra. But otherwise, all the other fields are same. Okay. So any question on type 5? We'll discuss in detail when we discuss about L3 VPN, right? Why we need router MAC extended community and other stuff. Okay, so let's now move to L2 EVPN. So far, we have discussed different route types, type 1 to 5, right? Which one will be used for in which case, right? L2 EVPN type 1 to 4, and also in 2 and 3 will be in L2 EVPN, and 1 and 4 for multi-home, right? And type 5 is for L3 EVPN. And before that, we also understood, different models, that VLAN based, VLAN aware, right? Bundle services, different bundle services. Now let's discuss L2 EVPN, and then after that L2 EVPN, L3 EVPN. Okay. So now we will start L2 EVPN. So before we start layer 2 EVPN, right? What are the advantages of EVPN compared to our normal VXLAN? Correct. So we already have discussed this, but let's quickly go through, right? So one main is, yeah, no more data plane source MAC learning, right? Flood and learn. So normal VXLAN, to learn the MAC address, you need to receive the data plane traffic. And based on that, you will learn the MAC address. But now, as soon as your local VTAP learns the MAC, it will advertise as type 2 route, right, to MAC and ARP information. So that is, advantage of L2 EVPN. MAC address is synced as soon as through type 2 update. BUM flood HER hidden replication, you don't have to configure manually, right? That also will be synced automatically by type 3 update. Even for multi-homing, so if you have normal VXLAN, you don't have anything for multi-home, right, when MLAG is not there. So that's how, EVPN will be helpful, where you have type 1 and type 4 update messages, which will take care of your multi-homing environment, right? Now the concept comes in L2 EVPN is integrated routing and bridging, right? So basically IRB is nothing but what we say is SVI, right? So we have on routing VTAP, we have SVI for VLAN 100 and 200. So IRB is synonym of it. So it's same as SVI. We'll discuss more about this integrated routing and bridging, right? But there are three different flavors of IRB model. Basically L2 EVPN, there are three different ways we can, design that. One is asymmetric IRB, right? Next is symmetric IRB, and then centralized gateway. So these are three different ways we can, design our L2 EVPN: asymmetric, symmetric, and centralized gateway. Next section is we will discuss what is IRB, right? And then we will discuss one by one asymmetric, symmetric, along with labs, okay, and then centralized. So yeah, let's first understand again, what is IRB, integrated routing and bridging. So it's nothing but, it's a one device or VTAP which function as L3 as well as L2, right? So basically, if you have one VTAP, right, and host is connected in VLAN 100 and another host is connected to VLAN 200. So what you have to do is you have SVI for VLAN 100 and 200. You receive the packet here, right? Route it into another VLAN 100, 200 and send it out, right? So this is not called RBI, IRB, right? Integrated routing and bridging. So basically you are routing from one VLAN to another VLAN and then bridging into that VLAN, right? So that's why it is called IRB, or we also call it SVIs, right? That one is one routing between one SVI to another SVI. So that's the concept of IRB. To get more detail of it, let's go on next section, right? So this is next slide. So this is, let's say, consider this is one VTAP, right? So this is one VTAP. Same example, right? You have two SVIs. This is one SVI 100, another SVI 200, right? So this is, yeah, this is one SVI 100, 200. You have two MACWAF 100 and MACWAF 200, right? That is configured under router BGP with RD and RT. Now you have server, which is part of VLAN 100, right? And another server is part of VLAN 200, and you want to communicate between these two, right? So what will happen? This server will send the packet to the gateway, right? SVI 100 gateway, and this will be the packet. So source IP will be its own IP address of server 1 or 12. Destination IP, server 22 IP address, this IP address. Source MAC is its own MAC 12, let's say 12, and destination MAC is SVI gateway MAC, right? IRB 100 MAC. So this is gateway MAC. You receive the packet at the gateway, right? What you do is you strip off this L2 header, right? You check the destination IP. What is the destination IP, right? So basically you strip off the packet, you check the destination IP, it is directly connected SVI, right? That SVI is already with you, directly connected. You route the packet, right? So you route the packet bit from VLAN 100 to 200, right? And then you have to send that packet to the destination host, right? So what you have to do is you have to add the L2 headers, right? So your source MAC will be IRB MAC, this MAC, right? Switch MAC, and destination MAC is your server MAC, right? You will send out ARP request if you don't have ARP updated, get the ARP reply back, and you update this MAC, right? So this is how, this is nothing but is IRB, right? Which we also say it as a SVI, right? So this is how this is the concept of IRB. Basically, your VTEP is working as routing plus bridging, right? Routing and bridging. That's why it is called integrated. Routing and bridging is combined, integrated into one switch. Okay. Any question? Okay. So that's how, if we proceed further, so basically we have to build this L2 packet, right? This, and for that we need to know the ARP for the server, right? This switch. So it will send out ARP request. It updates its ARP table once ARP reply is back from this guy, and whatever this server MAC, that will be placed here, right? And then this packet will be forwarded to the server. So yeah, this is how it will build the L2 header and IRB box, right? Basically, this is what the concept of IRB. Is it clear? If there is any question, or if you are not clear, I can, we can go through again.
No, it's just interval and routing, right?
Yes, interval routing. Just name is IRB. It is
Yeah.
named as IRB, but there is nothing much, difference. It's same as VXLAN. There is nothing EVPN in this, right? It's just name. Okay. So now let's discuss asymmetric IRB. Okay. What is asymmetric IRB? See, again, asymmetric IRB, it's not a new concept, right? You guys all know VXLAN direct routing, right? VXLAN direct routing, right? That is a asymmetric IRB. Can anyone tell me what is VXLAN direct routing?
For all the subnets, gateways are present in all the VTEPs. Means
Yes.
they are directly attached.
Yes. So SVIs, right? All the SVIs. So let's say in your data center, right? In your data center, you have, let's say 50 VTAPs, right? 50 VTAPs, 50 VTAPs or VTAP pairs, and you have 100 VLANs, 100 VLANs, right? So direct routing means all this SVI or gateway for all this, all this gateway SVIs, right? SVI means gateways for all these 100 VLANs are present on all 50 VTAPs. So all VTAP has, basically all VTAPs are routing VTAP, right? L3 VTAP, routing VTAP, right? And they have all the SVIs, all 100 SVIs are present on all the VTAPs, right? So what will happen is, when this server has to communicate with any other server, right, from this server 13 to server 23, it will first reach out to the gateway, which is first hop VTAP. So always your first hop VTAP is the gateway, because all our routing VTAP all has SVIs. So it will reach out to first hop VTAP, right, gateway. Then it will check the destination IP, which is 1103. It will check that, hey, that gateway destination IP belongs to another VLAN 200, which is directly connected, right? Directly connected, that subnet. So it will route the packet from this VLAN 100 to 200, right? Internally on local VTAP itself, first hop VTAP itself. And then it will send out ARP request for this guy, receives the ARP request, reply, and then bridge the packet, right, to this guy, VTAP, and then decapsulate the packet and send it to the server. So basically, if you have noticed, server reaches to the gateway, first VTAP, which is first VTAP for it. And first VTAP has both the SVIs. So it does routing and then bridging. Okay. Now let's check about the reverse route, right? Reverse traffic. So now 23 will again reach out to the gateway, right? Its own gateway of VLAN 200 when it has to send packet to this guy. It checks the destination IP, which is 1203, which is again directly connected route VLAN SVI. So it will route the packet from VLAN 200 to 100. So as you see here, right, your gateway is first hop VTAP, right? As soon as you reaches first hop, your gateway is there, SVI is here for both the VLANs. You do the routing locally here on this VTAP, and then you do the bridging, right? You send out the packet bridging and decapsulate and send. So if you see the difference, right, for forward traffic, routing is done here on this VTAP. But for reverse traffic, routing is done on this VTAP, right? It's not the same VTAP as done routing from VLAN 100 to 200 or 200 to 100. It is not only one single VTAP, right? The first VTAP, which is connected to the host, will do routing and then bridging. Similarly, for reverse traffic, this another VTAP, right? So that's why this is called asymmetric routing, right? Asymmetric means routing will be asymmetric. It's not only single VTAP will do routing every time for forward and reverse flow. So that's why this is called asymmetric routing. And the direct routing, right? Direct routing, we know that all SVIs are on all the VTAPs. But asymmetric is, the reason is your routing is not symmetric, it's asymmetric, right? So that's why this is called asymmetric IRB, which is also called direct routing. We will see pros and cons of it, right? While we discuss more about this. But yeah, any question if you are not clear on this? Okay, so it's the same as VXLAN direct routing. Okay, now let's discuss more about, you know, how this packet flow works, right? So this is again it's not, it's same concept of VXLAN, more of it, right? So let's understand this. So there are this two hosts, right? H1 and H2, both are in different subnet, right? This 11.11.10 and this is 12.12.12.11, right? Gateway is locally. So both are here locally, local gateway. 1 minute, not this one. This is more confusing. Let me pull up another diagram. Yeah, this one. Okay, so yeah, so you have 10, 10, 10, 10 host and 20, 20, 20, right? So this is, let's say VLAN 100, right? VLAN 10 here. Okay, so VLAN 10, right? And VLAN 20, right? So you have SVI configured on both the VTAPs for VLAN 10 and 20, right? Both sides. Okay. Now you want to communicate between H1 and H2. See, basically right now what we are going to discuss is each VTAP has how many tables we are going to refer, right? When we route packet between H1 to H2, which is in different subnet, how many tables we are going to refer, right? Or we are going to update. So as soon as H1 sends out the packet, right, to the gateway, it will update the MAC table, right? So local MAC will be learned, right? MAC table. So MAC H1 will be learned here, right? In particular, this VLAN 10. Okay. Now, and this MAC will be advertised, MAC and ARP both will be updated, right? And that will be advertised as, so you have MAC table, you have ARP table, right? As soon as you learn this sends out ARP request, right? So you update MAC and ARP table, and both will be advertised as type 2 route, so that the other guy will also learn the MAC and ARP, right? MAC and ARP table update. It will update with this guy H1, right? Information. So these are the two tables which are involved, right? Now you receive the packet to the gateway, you check the destination IP, right? It is 2020-2010. So now to understand where to send this packet destination IP, which table you will refer? See, you receive the packet, right? Destination IP is this. Now what you will do?
Do the route lookup.
Route lookup, right? So third table you will check is route table, right? Routing table. So you will find that, hey, connected route for 20.20.20.0. 24 is directly connected, right? Directly connected to VLAN 200 or 20, sorry, VLAN 20, correct? So basically, what are the tables involved? Okay, so you do route table, then you send out ARP request if it is not already there, right? And learn the ARP address for H2 as well, right? So H1 and H2 ARP, right? And also you will update the MAC for H2, correct? In VLAN 20. So basically, and then you forward route the packet from VLAN 10 to 20 and then bridge the packet, right? Bridge the packet. So basically, these are the tables, right, which you need to update or populate. That is, one is MAC table, another is ARP table, and then route table, right? To forward the traffic from one end to another end. There is one more table, VXLAN address table, right? Which is, we can consider it as part of MAC table, right? So basically, these are the three information we have to update, right? So yeah, so that's what is we are discussing here, that asymmetric IRB, how many different types of tables we have, right? Or we need. So we need to populate. So one is MAC table, right? So one is ARP table. So we have to populate the ARP table, right? Based on type 2 our route updates. Another is MAC table, right? And so we have to update, populate MAC table again based on type 2 update. So MAC table, ARP table, and then routing table, right? So routing table. So we have to update the routing table, right? Route table. So these are the three tables, right? We need to update, say MAC, ARP, and routing table. So basically, yeah, these three tables are needed to forward the traffic. Okay. Any question? If any of this is not clear. Okay. Okay. Now let's again, this is the nothing but packet walk, right? So let's say you have server 12. Okay. And you want to communicate it with server 23. It's two different VTAPs. So this is VTAP 1 and this is another VTAP, right? And you want to communicate between these two. This is in VLAN 100. So you have SVI 100 here on this VTAP and 200 also here on this VTAP, right? Both SVIs are present on this VTAP. Similarly, here you have SVI 200. Okay. We are just right now discussing the forward path. Okay. So what will happen? So again, server will send the packet to the gateway, right? You will check the routing table, right? So first you will check the routing table, right? And you understand that, hey, it's a destination IP is another SVI 200 connected route. You route the packet between 100 to 200, right? Now you have to send packet to the destination host, right? So for that, you need to know the ARP for this 2203. So you will check the ARP table, right? So first you check the route table. Now you are checking the ARP, right? ARP table, that how to read this particular destination ARP IP, right? What is the MAC? So you get to know the MAC address of this through ARP table. You update your header, right? Where destination MAC is this MAC of server, right? 23, correct? Server MAC.
No, Vishal. So this ARC table, this is populated by BGP table, right?
Okay, so this ARP table is, you mean to say type 3 route, right? Type 2 route, right? Type 2. Yes,
route.
yes.
Yeah.
So
Okay.
see, this is how it will happen. Okay. So let's, okay. So is it clear that, you route into VLAN 200, right? Is it, it's clear. Now you have to send packet to this guy, right? 2203. Now there are two possibilities. Either ARP for this destination IP, right, is already updated 2203. This is already updated, okay, in your ARP table on this switch. 2203 is 23, okay. Now, when this will be possible, if this is already updated, what are the chances, or when will it happen?
That there was already communication between these two.
Yeah, so basically, if this ARP, right, this host ARP is locally learned here, already ARP table is updated for this guy, right, locally, that is 2.2.03, right, which is 23. Now, when it will come happen, so let's say server, this host, as soon as maybe it has come up, and if it has communicated to gateway, right, or even to any other host, right, it, as soon as it sends the packet, ARP request or anything, it will, the local MAC and ARP of this guy will be updated, right, on this switch. And as soon as this MAC and ARP is locally learned, it will advertise type 2 route to this guy. So possibility of this ARP is already there on this device learned using by type 2 route is quite high, right? Even though this guy has communicated with gateway or any other device in the network, and you will learn locally MAC and ARP, and that will be immediately advertised to all the folks, right? So that is one reason that you might have ARP already there. But there is another scenario, right, where this host has never communicated with anyone. Now you have to send the packet to this host, right? So what you have to do is you have to send out for our first ARP request, correct? So you send out ARP request, right? ARP request, because you don't have ARP updated. ARP table is not updated for this guy, okay? Now this will send out the reply, okay, in VLAN 200. Now, if you know, as you know, here we have SVI 200, correct? SVI 200 is there. And we also have virtual MAC configured here. So when this guy reply back to that SVI IP and virtual MAC, this VTAP will consume that packet, because that IP and MAC is here also, right? So basically it will learn the ARP, it will update the ARP table, right? It will update the ARP table that, hey, to reach this particular IP 2.2.0.3, right? The MAC is 23. So obviously you don't have to send the ARP reply till here who has originated. But what will happen is, as soon as this guy updates the ARP table, it will generate type 2 route, right? For MAC, it will also update MAC table, right? So it will generate type 2 route with MAC and ARP information, and that will be sent here. So basically this guy will now learn based on type 2 update message, this will learn MAC and ARP table, right? It will update MAC and ARP based on EVPN routing information type 2. Okay, is it clear?
Yeah.
Okay, any question? Okay.
This is all coming through spine, right?
Yeah, yeah. So yeah, here we have not shown that, right? But yeah, it will be through spine. But it's not necessary. See, you can have network where, you know, these VTAPs are connected through L3 or any in between any L3 networks. It's ISPs also, right? ISP and multiple devices. So that's fine. In fact, there is one design which is very rare where between two VTAPs, they use L2 circuit, layer 2. Okay. Some of the customer, it's very rare, but that's also there. So spine is just a medium, you know, because there are many VTAPs, you can't have connectivity between all VTAP full match, right? So that's just spine is just to fulfill that basically. Yeah. Okay. Any question? Any other question? Okay. So now let's, okay. So now we discuss about, you know, forward path. Now let's talk about reverse path, right? The reverse traffic. Now in asymmetric IRB, as you have noticed in the previous one, we do not have SVI here, right? For VLAN 100, we don't have SVI here in the previous this one, right? But that should not be the case in asymmetric. As we know, all the SVI should be present on all the VTAPs, right? So basically we need to have SVI here as well, right? And that's how this looks like, right? So even this VTAP also should have this SVI configured 100, even though there are no hosts behind this VTAP for VLAN 100. Even though there are no hosts behind this VTAP for VLAN 100, still you need to configure this SVI, right? 100 here. So this is unnecessary. Basically, you need to have all the SVIs all on all the VTAPs, right? That's the concept of direct routing or asymmetric, right? So now what will happen when this guy has to send packet? It will send to the gateway, right? It will route the packet into 200 to 100. SVI is also present here. And from there, it will bridge the packet to the end host, right? So this is one limitation you can say of asymmetric IRB, that even though you don't have any tenants or host, still you need to have SVIs of all the VLANs. In case in your DC, if you have 100 VLANs, you need 100 SVIs. Okay. So this is not only one limitation, there are many which we will discuss. So this is one of it, right? That now if you have SVI, right, VLAN 100, basically you need to configure VLAN 100 here, right? SVI here. So you have to also have to configure VLAN to VNI mapping, right? So for VLAN 100, you also have to configure VNI, whatever, let's say 1000 here, right? So basically for all the 100 VLANs, you also need to have VNI configured on all the VTAPs, even though that there is no host for that, right? So that is, one more reason, limitation, we can say. Okay. Any question? Just a minute. Okay. Yeah. Any question? Okay. So what is the configuration, right? So configuration is same as, our direct routing, that on all the VTAP, you need to configure all the SVIs, right? All the SVIs on all the VTAP. So if you consider this as one VTAP, then config, as far as configuration is concerned, you need to configure SVI 10 and 11 on this VTAP, right? And also under router BGP, you have to configure VRF for VLAN 10 and 11, right? VLAN to VNI and VLAN to VNI mapping under VXLAN, and VRF, right? MAC-VRF, RD and RT values for all the VLANs. So basically, in asymmetric IRB, if you have 100 VLANs, right? 100 VLANs, what are all the configuration you need to do on all the VTAPs? So SVIs for all the 100 VTAPs, right? VLANs, VLAN to VNI mapping for all 100 VLANs, and MAC-VRF configuration. MAC-VRF configuration for all the 100 VLANs, right? MAC-VRF for VLAN 1, 2, 3 to 100. If you are using VLAN aware, then you can combine multiple VLANs with same RDRT, right? So that option is there, but basically you need to configure all this, right? Is it clear? Any question? Okay. So yeah, and again, to reiterate that IRB is nothing but SVI, right? Inter-VLAN routing. Okay. So let's go through. It might be repeated, but yeah, let's go through the packet walk, right? Between two servers, right? Between these two servers, which are in different VLANs and on different VTAPs. So what you will do is you will send the packet to the 1 minute. I think, okay, so you send the packet to the gateway, right? So source IP will be the IP address of the server 1202. Destination IP is the destination 2202. Source MAC is the 12, and destination MAC is your gateway MAC, right? You receive the packet here, right? You strip off this two, right? MAC. You check the destination IP, correct? So that's what you do here. Then let's go to next. So now what you are going to do is, you check the destination IP. Destination IP address is belongs to SVI 200. You route the packet to 200. Now you check the destination IP is this. Check the ARP table, right? If MAC is already learned, you replace the destination MAC with that MAC, right? And source MAC is your IRB MAC, right? VTAP MAC, and send out this packet, right? Update this and send out, breathe this packet. Next, yeah,
Sorry,
go ahead. Yeah.
this would be my VXLAN's inner header, right?
Yes. So yeah, so this is step-by-step process, right? So see, here you have source IP and destination IP, okay, right? Now you check the destination IP, you have to send packet to this guy. So for that, you have to add the destination MAC and source MAC, right? To create the packet, right? So yeah, you are creating this packet, right? Then this is your inner packet, right? This is your inner packet. Top of this, you have to encapsulate the packet, right? Because you have to send that out to another VTAP on VX1. So this destination MAC is learned on VX1 interface, and that is behind VTAP 2, right? So if, okay, let's go through step by step, right? So you came here, and this is your source IP and destination IP, right? At this point, you check that destination IP is directly connected, routing table directly connected, right? So you route the packet from VLAN 100 to 200. Now you have to send the packet to this destination IP. You will check for the ARP. If it is already learned, then you replace that destination MAC here, right? Because to send the packet to this guy, you need to know the destination MAC. If your ARP is already populated, you replace it with the destination MAC. This is source MAC is your own MAC, right? VTAP MAC, and then source IP and destination IP intact. Okay. Now you check that, hey, this is my destination MAC. I want to send this packet to destination MAC. You refer the MAC table, right? You check the MAC table. Hey, on which interface I have to send this packet out, right? And you understand that S22 is learned over VX1, right? So now you understand that, hey, to send the packet to this destination, I have to send packet to the VXLAN, right? Now, which VTAP, behind which VTAP, you don't know that, right? So you consult VXLAN address table, right? VXLAN address table, that S22 is behind which VTAP. So it says you that it is behind VTAP 2, right? Which is nothing but whatever VTAP IP here, 2222, right? So now you have all the information that I have to send packet to this destination MAC, right? For that, I have to encapsulate the packet. I have to add the VXLAN header, right? And what is the VTAP IP? Outer VTAP IP, destination IP is 2222. So basically now you build the VXLAN header, right? This will remain intact. What is this, right? Which VLAN you have to send the packet? So it's VNI 200. So you add VNI 200 as a VXLAN header. Destination VTAP IP, you know that source MAC 22, MAC 22 is behind VTAP 2222. So you add 2222 here. So destination VTAP, source VTAP is your own VTAP IP, right? Let's say 1111. So that is 111 here, right? Destination MAC. So now this is between these two guys, right? Or if in between spine, then between spine and this guy. So this will be destination MAC. This will be source MAC outer, right? Source MAC and destination MAC. So basically you are creating this packet, right, to send this out and then send this out here. Is it clear?
Yes.
Anyone has any question? Okay, perfect. So let's move forward, right? So now your packet has come here, right? VTAP2 has received the packet. What it will do is it will remove this VXLAN header packet, right? It will strip off this. Based on this, it knows that, hey, I have to treat this packet or forward this packet into VLAN 200, right? Now it checks the destination MAC. Destination MAC is already learned on this interface, right? So basically it will consult its own MAC table, and based on destination MAC to interface mapping, it will forward the packet to the destination server, right? So this is how, packet walk will be in VXLAN. It's same as VXLAN, right? There is nothing new. The only difference between VXLAN and EVPN, right, is that the MAC and ARP is learned through EVPN. That's it, instead of data plane, right? But otherwise, this whatever we have discussed is what is we also have discussed during VXLAN, right? Just learning of MAC and ARP and all that is through EVPN. That's it. Okay. So you can very much, correlate this as a VXLAN direct routing. Okay. Okay. Any question? Okay, so after this is the different limitation, but before that, let me take a pause and ask you if anyone has any questions related to a IRB concept and a symmetric IRB. How packet flow works, or if you want, we can go through again. Okay, so looks like that everyone is fine. So let's go move forward. What are the limitation, right? So one is limitation of MAC exhaustion, right? So see, this is your one VTAP, right? In your network, you have, let's say 2, 3, 4, and there are 100 VTAPs, right? 100 VTAPs, right? Now all VTAP, let's talk about VTAP 1. You have to learn or you will learn the MAC address. If you talk about MAC address table of this VTAP, it has obviously learned MAC addresses of all the local VTAP hosts, right? So all the local hosts, it is there, 1, 2, 3. Let's all this local host. But if you observe, you will also learn the MAC address of all the other VTAP behind other VTAPs, right? Because what you do is, let's say this is VLAN 100, right? And you want to send packet to this VLAN 200. So you route packet from 100 to 200, and then you check the MAC lookup, right? You should have this MAC learned here locally, MAC 2, right? MAC 2. And then you have to bridge that packet, right, to this guy. So basically all this MAC address behind all the hosts, right, it should be learned on this VTAP, right? So let's say you have 100,000 hosts in your network, right? Out of these, whatever hosts are actively communicating, right, all that MAC should be learned on this VTAP, and not only on this VTAP, on all the other VTAP. So basically MAC table on each of the VTAP will be of 100,000 entries, right, for all the hosts, assuming all are interacting, or MAC is not flushed out, right, age out for particular host. So more or less, you need to, basically idea is you have to learn all the MAC address across your DC or all the hosts, right, on all the VTAP. So it is very much possible that, you know, all VTAPs might not support that much scaling of MAC, right? So let's say for customer might have used 720 XP device, yeah, low end switch, right? Arista 720 or 710, which does not support scaling of this much MAC address. So in that case, you can't use asymmetric IRB, right? Direct routing, right? Because here you need to have MAC address learn on all the VTAPs. Okay. Is it clear? Any question? Okay. Yeah. So similar limitation is, you know, VNI scaling, right? So again, as we know, as we discuss here, right, in this scenario, even though this VTAP2, right, VTAP2 don't have any host for VLAN 100, right? VLAN 100, there are no hosts, but still you need to configure SVI, right? You need to configure SVI for VLAN 100, MACWA for VLAN 100, and VLAN to VNI mapping for VLAN 100, right? So basically you need to configure everything, right? VLAN to VNI mapping. So again, if we come to the same discussion that across DC you have 100 VLANs or 500 VLANs, you have to configure VLAN to VNI mapping for all these VLANs, right? On all the VTAPs, even though there are no hosts for some VLANs under it, right? Still you have to configure this VLAN to VNI mapping, which is again might cause issue for low end switch where VNI resources are limited, right? Or it does not support that much scaling, right? So this is another, you know, limitation of asymmetric. Okay, now let's move to the next one. Just give me a minute. Okay, so again, it seemed true for ARP as well, right? So if you see here, this VTAP, right? You want to send packet from this guy to this guy. Basically, you need to learn the ARP address of the destination host, right? Destination host, which is server 23. So ARP you have to learn, right? So basically, if you have 100,000 hosts in the network, you need to have ARP locally learn for all the hosts. Even though hosts are behind other VTAP, you have to learn ARP for that host, right? So basically for all the hosts like MAC address, you need to have ARP updated, right? Because you are doing bridging from here, right? Locally routing and then bridging. And for that you need ARP, right? So basically you also need to learn ARP for all the hosts, and that is true for all the VTAP. So even though this guy don't have any VTAP 100 or VLAN 100 hosts, still it has to learn ARP for all the VLAN 100 hosts which are behind the other VTAPs, right? This guy still has to learn ARP for this host, right? This host to send the packet, reverse packet, right? So basically it's same as MAC table, right? You need to have that much capacity of ARP table, right? So these are the, you know, these three are the main limitation for asymmetric IRB, which is same limitation for your direct routing, right? We explained direct routing. So one is MAC, another is VNI scaling limitation, and then ARP exhaustion, right? Because ARP small devices might not have this much capacity of ARP, right? Any question?
Is there a way we can map like a single VNI to multiple VLANs?
Sorry, come again. Single
VNI to multiple VLANs? Because
no.
we are
Okay, yeah, go ahead.
importing the route target, right?
Yeah, we are importing route target, but that is for control plane, right? But what about data
Okay.
plane? Data plane, we don't have RT, right? We are only dependent on VNI to figure out, hey, this packet belongs to which VLAN, right? And if you have multiple VLAN points to same VNI, there is a confusion, right? In data plane traffic.
Can we, like in the inner header, right?
Mm-hmm.
Can we not add .1q tag?
Okay. So see one, okay. So this, see one thing, right? See, let's say that this is VTAP, right? Normal switch. This is your L2 host connected, right? And this is your L3 connection to any other switch, right? So when you get the packet here and when you have to send it on L3, even naked packet, right? Without VXLAN, do we add .1q? No, right? Right?
Yeah.
That's only on trunk port, right?
Yeah.
So basically, see, you have to tweak everything then, right?
Got it.
Yeah. So yeah, so to answer your question, and as already you know, right, that's not possible because data plane, we are sending only VNI information, right? Not the RT value. But yeah, that was good question, right? For everyone's benefit. So as we see here, right, see this data plane traffic, the only way to identify VLAN, which VLAN this packet is going to be, right, belongs to is VNI. So we can't map same VNI to multiple VLANs, right? We can't map that. RT is only for control plane identification. Okay. Any other question? Okay, so I think let's just quickly go through so that we are done with this asymmetric concept, and next time we can go through configuration and lab. So it's again, it's repetition only, right, of that what we have discussed so far, or we have discussed VXLAN routing. So basically this is server 1, you wants to communicate with this server 4, right? It both are in different VLAN green and blue, right? What you will do is server 1 sends the packet to the gateway, right? You learn locally MAC and ARP. So you learn locally MAC and ARP, right? You generate type 2 route for MAC, right? Type 2 route for MAC and type 2 route for MAC and IP ARP, and advertise that route to here, other VTAB, and you update the MAC table for this MAC and IP ARP, right? This guy, you update the MAC and ARP table based on type 2 route you receive. And this is the configuration on both sides, right? That you have RD and RT for MACWOF 10 and RD and RT for MACWOF 11, and also VLAN to VNI mapping under VXLAN, right? So this is the configuration at both ends where RT is same for that particular VLAN, right? Here typo, it's VN011, right? So basically, yeah, you then receive the packet, send type 2 route packet from one VLAN to another VLAN, right? Green to blue, and bridge the packet here, decapsulate the packet and forward it here. Reverse packet comes to the gateway of blue VLAN, right? Check the route it into the this green VLAN, blue to green VLAN, and then check the ARP and MAC of this guy and forward it to this particular VTAB directly, and then send it out, right? So basically this is how packet flow will work, right? In asymmetric IRB or even in VXLAN direct routing. Okay. The next is again same thing, but just step by step, right? So you send the packet to the gateway, traffic routed by local Anycast IP gateway from green to blue. So it will route the packet from green to blue, right? This is the MAC and all the information. You encapsulate the packet, right? Encapsulate the packet with outer header information, and this is the original packet. It is received here, right? So it will be encapsulated. You receive here, decapsulate the packet, remove this headers, and forward that packet to the server 4, right? Just step by step at each stage what you will do, right? What processing. So yeah, that's all about VXLAN asymmetric routing. Any question before we, wrap up for today? If you have not understood. Okay, so then great. I think next time, next one session, we will, understand the topology, right? And also the configuration, and then we will do lab, right? Verification. So that will be part end of our asymmetric, and then we will again discuss the same way concept of symmetric IRB, which is little bit complex. Okay, so we'll discuss symmetric IRB and again followed by lab and configuration of it. And then we'll see if we need to do centralized, but otherwise it's combination of this. So we'll see that. Okay, so let me stop recording and yeah.